In this video, we're going to do a crash course on summarization using LangChain. Let's get started. So we're going to start with the easy stuff first. I already have this Jupyter notebook completely set up, and we're going to walk through this Jupyter notebook, and we're going to do a few things. We're going to do first the simplest summarization we can do using LangChain for a small PDF. Then we're going to try it out on a big PDF. And then we're going to explore some of the problems that you might encounter if you're dealing with large documents. And we're going to look at some approaches to fix those problems. We're not going to solve every single problem of summarizing with PDFs, but ideally, we're going to be covering everything you need to get started with LangChain and be able to do summarizations and custom summarizations. So the easy stuff first. The imports we're going to do is we're going to start with the load summarize chain, which is going to be the basic chain that we're going to use to do the summarizations. We're going to import prompt templates that we're going to use for doing custom prompts. We're going to import PyPDF loader, which we're going to use as our document loader for PDFs. And we're going to use LangChain chat models, Chat OpenAI, which is going to be our interface with ChatGPT from LangChain. And I'm already going to set up my LLM here. I'm going to set up the ChatGPT, GPT 3.5 Turbo, and I'm going to set up temperature to 0 because I want these summarizations to be as precise as possible. And if you guys don't remember, temperature is a measure of, let's say, how random the ChatGPT model is allowed to be. So like if the number is a bit higher, between 0 and 1, higher the number, more creative the model is, sort of. And lower the number, more precise the number is. Okay, so a basic summarization, we're using LangChain. We have a PDF file path, right? In here, I'm using, setting up this small PDF, which is just a paper on some topic. In this case, is about the effects of short-term video, or the effects of short videos like YouTube Shorts or TikTok on intentions in the brain. Pretty cool, interesting paper, actually. So I'm going to load it with PyPDF loader, and then I'm going to run load and split, and we're going to talk about what we're loading here and what we're splitting here, but let's just run the code. We're going to set up the load summarization chain using a chain type called MapReduce, which we're going to discuss later, and then we're going to run that summarization. And when I do that, I get this summary, right? This article reviews 15 studies that examine the effects of social media use on memory, cognitive control, task switching, perspective memory. Results show that short-form videos have a significant detrimental impact on perspective memory performance, while the other platforms do not significantly affect performance. The article looks at the effects of interruption of task execution, etc., etc. Perfect. That is a perfect rendition of this paper. We can do a quick check just for you guys to see. This is the paper. So yeah, perfect summary. Okay. But now, let's say that we look at a PDF that's a bit bigger, or, it has more tokens than the PDF that we were using here. What happens then? Well, this is what I'm doing. I'm doing the same thing that we did for the small PDF, and you probably encountered this when you were trying to use LangChain for summarization, which is you run into this issue. Where is the error? Let me get the error for you guys to see here. And there we go. So we run into the dreaded token limit issue. So in this case, you've requested 7,929 tokens in your prompt plus the completion, and please reduce your prompt or completion length. Okay, so that's annoying. So let's ask the question, why doesn't it work? And what is context length? And let's start with context length. So context length in ChatGPT, in large language models in general, refers to the maximum number of tokens that the model can consider when it's generating a response, right? So there's a certain amount of context that the model can encode, and that context is measured in terms of tokens, which are these very small units that represent what a model, the simplest thing a large language model can generate. So to understand why this thing doesn't work in context length, we have to understand tokenization. So let's just stop for a minute and understand what tokenization is. So what's a token? Now, traditionally, a token is the smallest unit of text that a model can understand and generate, right? So depending on the language and the tokenization method, a token can be a single character, a word, or even part of a word. All right, so what does that mean? A token is some unit of text that was generated programmatically somehow according to some predefined rules, and that can be many things. So the example that I chose to showcase here is one where we just get a sentence and we split it by the white space so we get the words in return. So those could be my tokens, okay? So that's an example of a token. Now, GPT models have a bit of a different approach to tokenization, and we're gonna look into what approach that is. So the first thing I'm gonna do is I'm gonna open up this website, which is has the tokenizer as a tokenizer demo from OpenAI. And what we can do is I can copy this phrase, ChatGPT is an AI, I can paste it right here, and there we go. It tells me that I have 6 tokens, 16 characters, and it color codes the phrase, the sentence, according to its tokens. So it's chat, GPT, is, and AI. Awesome. Now, what this thing here is doing is what I chose to put it here. So actually, I went to grab part of this code from the OpenAI cookbook, which you should check it out. Pretty cool GitHub repo, and they have a lot of cool information there about OpenAI models and stuff. And what I'm doing here is I have a sentence, and I'm using the tick token package to encode using the GPT 3.5 Turbo. So we're gonna do the same tokenization that occurs in the GPT model. So we're gonna encode it, and then we're gonna decode it in token by token, and then we're gonna print that as a list. And this is what we get, which matches what we're seeing here on the right. Okay, cool. So you have a way of splitting sentences into these little bite-sized chunks, which are the tokens, right? And what we're gonna be doing is, we have to understand that those little chunks make up when you sum them all together, when you have like a certain context length, you have a certain amount of those little chunks that you can put in a GPT-like model. Because much like, many transformer models, you have a fixed size window for context in these models. So you have a certain amount of context that they can encode at once, right? So what happens? When we have this issue of token limit, the model starts forgetting all those parts of the conversation as it continues to generate responses. That's why GPT-3, like many of these models, have these fixed size windows of attention, right? Let's remember that transformers were amazing, partially because they solved the problem in RNNs, which was that problem of the catastrophic forgetting, right? But they're also plagued here somewhat by this idea of a fixed size window of attention. And that connects to the complexity of maintaining coherence over longer text spans, which is something that we're not going to get into in this video. Now, for summarization, how can we fix this issue? Now, LangChain is awesome. And LangChain is awesome because what they did is they developed a few paths, a few ways that you can get around this context issue through approaches that involve splitting documents into smaller chunks and then applying summarization to these smaller chunks and then combining them in different creative ways in order to get a decent summarization. So let's get an example here. So here, what I'm going to be doing is, I'm going to be doing the simplest, silliest thing that I could do. I'm going to do, since this is a paper, I'm going to just run summarization for the first 5 documents saved in this docs variable, which was created with the load and split method, which essentially gets a document loader and turns that into a list of document objects, which we then feed to a load summarize chain to get our summarization. And what we get is a decent summary of those first 5 documents that were created, whatever they are. Okay, so this is not enough for us to do big summarizations, right? So to do big summarizations, we have to understand three concepts. We have to understand document loaders, text splitters, and something called chain types in LangChain. And if we understand those three things, we can learn to combine them in creative ways to do summarization of whatever we want to summarize. And we can also learn how to use them in smart ways to avoid issues with usage, for example, using ChatGPT models, because we know that, with a lot of token usage, you can spend a lot of money, like by mistake somehow, by doing the wrong approach or the suboptimal approach. So what we're doing here, is very simple. We're gonna go through these three concepts very easily. So you have document loaders, and that's just document objects. They're based on something called unstructured, which is a package for handling unstructured data, okay? And essentially, this thing is getting all sorts of data types and formats and trying to put that into a unified text format, okay? So this is the unstructured, which is the basis for the document loaders used by LangChain, okay? And in our case, for PDFs and summarization, we want to focus on PDF document loader by LangChain, which essentially will just load a PDF and transform that into an object from which we can extract the text and do all sorts of things to it, okay? So we're using this PyPDF loader, document loader. So you have document loader, it's based on this unstructured package, which is a way to represent and convert different data into a unified text format. And we're concerned with the PDF loader. Okay, cool. So now, second thing is text splitters. Now, what are text splitters in LangChain? Now, text splitters are just a way to deal with long pieces of text that involve having to split them into a bunch of chunks. So you got to split big texts into chunks because you can't feed them directly into your model, into your large language model. So what you want to do is you want to use some form of document splitting technique. You want to split your big text into smaller pieces of text. And there are many ways to do that. Now, the LangChain is really cool because they have documentation on different types of splitters and how each of the approaches works and what it's doing to the text. But in general, you have these three big pieces of splitting a text. You have breaking it down into small semantically meaningful units of like sentences. So you got big text and you want to break it down into small pieces of text that have they're semantically meaningful, right? You don't want to have just like small pieces of text that just cut important parts of each other and just, separate things that should be actually together so that you can better understand context and things like that. Then after that, you want to gradually merge them into a larger section until it reaches a certain size. So you split and then you want to merge it together up to some size, some chunk size. And then after you did that, you have this chunk that you created and you want to incorporate overlapping elements to ensure context continuity. So in essence, text splitters are a smart way to split documents into intelligent chunks that you can use to make better use of large language models. And then you have chain types. Now, chain types in LangChain, we're talking about ways to interact with data that's indexed from which we want to do something. In this case, we want to do summarization. So there are a few types of chain types, which, funny enough, it's context specific, yeah. So there are a few types of chain types, and we're going to go through them from the simplest to the most complex. I'm following just the documentation that you can find on LangChain. And the way that it's done in the documentation is actually extremely intelligent because it goes from simplest to hardest, and it showcases the essential idea, the pros and cons, and why it matters, why you don't have just one type of chain type to do things like summarization. So you have, the first approach is stuffing. So that's the simplest approach you can do, which is essentially you get your text that you want to summarize and you put it inside the prompt. So you get a big prompt. And if it doesn't exceed 4,097 tokens or whatever context length the large language model has, it will work, right? So that's the most basic chain type you can find. So then you have MapReduce. Now with MapReduce, you're running an initial prompt on each chunk of the data, and then you have a different prompt that is run to combine all the initial outputs, which can scale to larger documents, and it calls to the LLM or independent, so you can be parallelized. However, it requires a bunch of calls. You may lose information. So what is MapReduce? MapReduce is you have an initial prompt on the first part of the data, so initial chunk of the data. And then what you do is you get that output, you run to combine all the initial outputs. So you can scale larger. Exactly. So then with MapReduce, what you're doing is you're summarizing different pieces of the document, and then combining those summarizations together. So you have one prompt that is used on each chunk of the data. So you separated your data into a bunch of chunks, and you summarize each chunk, and then you have a different prompt that is used to combine all of those summarizations that you created into one thing. So it's great because it can scale to larger documents, and the calls are independent, so you can parallelize. That's awesome. But if you have a bunch of chunks, you have a bunch of calls to an LLM, so it might not be optimal, and you might lose information. Then you have refine. So refine, again, this is the thing that I was actually confusing MapReduce with refine. So refine is you do the prompt on the initial part of the data, and then you iteratively add that output to the next part, and then you run a prompt on that, and then so on and so forth. So on the other hand, you can put in more context, but less lossy, but the other requires more calls to the LLM. Yeah, so it requires more calls than MapReduce. And what you're doing is you're running some prompt on initial part of the data, and then there's an output, and then you iteratively add that output to the next chunk, and then you summarize that, add that to the next, and you go on and on and on. So that is the definition for refine, the chain type refine in LangChain. And then you have map re-rank, which you're adding a scoring mechanism to these prompt summaries over chunks. So you run a prompt on each chunk of the data, and then you score those outputs, because you want to assess the certainty of the answer that you got from the prompt that you ran on some chunk. And then those responses are ranked according to the score, and the highest score is returned. It requires fewer calls than MapReduce, but can't combine information between documents. So you have this issue of like, you can combine information from different PDFs, but on the other hand, it's a really cool way to assess, you're able to model your certainty over the summarization that you're generating. So it's an interesting, different approach. I haven't played around a lot with map re-rank, but in essence, that's how it works. Yeah, so essentially with re-rank, you run a prompt on each chunk of the data, and then you give it a score to assess certainty, and then those responses are ranked according to the score, and the highest score is returned. It requires fewer calls than something like MapReduce, but you can combine information between documents. So now, when we try to run a summarization like MapReduce in this specific big PDF, we get an error, which is weird, right? Because, I mean, we've just learned that MapReduce is an approach that scales to large documents. So let's understand why I got an error for this summarization. I got an error because there was one of the chunks was too big. So if I look in here, I'm investigating the size of each chunk inside my documents. So I'm getting the number of tokens inside each document that I created and assigned to that variable docs. And I'm printing it if it passes the 4,097 token limit from ChatGPT. And funny enough, there's one of the documents that was generated had a bigger context length than we're allowed to feed to ChatGPT. So to fix this, we can use something called Recursive Character Splitter, which is a specific type of text splitter from LangChain, where they recommended to use for generic text, and essentially you split the text by a list of characters, and then the chunk size is measured by how many characters you have on that chunk. So the chunk size is measured by the number of characters. So when I use recursive character text splitter and I set chunk size, in this case, I'm setting it to 2,300 after some few experiments. And then I run create documents and run my summarization again using MapReduce. Lo and behold, I get my very effective and significant summary from that big document. So this is one approach, using recursive character text splitter as a way to circumvent the issue of the size of the PDF. However, it's not like this is absolutely perfect, right? There are many, many ways to do it that involve, for example, you could, there's an approach where you use clustering, where you embed your documents, and then you use clustering to select the best documents from that list of documents that we were working with, this docs, in order to get a better summary. There are many, many ways and many approaches of using embeddings, vectorization, vector stores, etc. And this is one that worked for me, and I think this is a fine one for like an initial approach with LangChain for summarization. Now, the final point that I want to address is how you do custom summarization. That was actually on my last video on summarization. I had a point about doing custom summarization, and someone asked in the comments, and I always try to listen when people ask stuff in comments and address it in later videos. So here we are. If you want to add custom summarization over any PDF, we'll take the example of this document that we have here, this docs. Okay, so we're going to use the same docs, but here I'm going to say I'm going to create a custom prompt, which is going to be a string that describes how I want the summarization to be. So I'm saying summarize the following paper into a set of bullet points, and I give it the paper. So then I feed that custom prompt into a prompt template from LangChain. So I set template to my custom prompt, and then I say that I set for the prompt template the input variables text, which is what's fitting here, which is going to be the paper, the text with the paper. And then I run load summarize chain. I use MapReduce again, which is a fine approach for this case. And then I set map prompt to the prompt template that I just generated, as well as the combined prompt do the same thing. So I'm summarizing all of those chunks using this approach. There are many ways that I could, play around with different custom prompts, etc. And on an upcoming video, I'm going to do a custom summarization app where I'm just going to build on top of this and just create a UI where we can address different parameters and play around with the different options that we can have for doing custom summarization using LangChain. But in essence, we're just using this prompt for the map prompt, and we're setting the combined prompt to the same thing. Finally, I'm running the chain and returning the output, and what I get in return is this thing here, which is essentially my summarization, an effective summarization of the paper, but using a set of bullet points, just like I asked. So it says this particular summarization, this PDF is the Tree of Thoughts paper. My latest video was on a review on this paper. This is a fascinating paper. And effectively, it discusses this idea of, injecting decision-making and planning capabilities to large language models by leveraging some interesting approach where you search over possible thought sequences and then you select best paths so that the model can learn to deliberately think over possible thought sequences. It's really cool paper. So the paper proposes to your thoughts paper, etc. So I have my bullet points, as you can see, bullet point, another bullet point. I can even put this in a little text so you guys can see a little bit better. And you can see all the bullet points were generated, right? Which I could put it here. And then if we compare with the summarization that we got from the, let's call it traditional approach, you can see that it's quite a different summarization. Yep. So this is a more, dense essay type summarization, maybe a bit more complete. But the other one is a customized, and I could customize this in whatever way I want. I can say, I want you to give me introduction, development, conclusion, etc. So that's how you do custom summarization over any PDF using LangChain. And I hope you guys liked the video. If you like it, don't forget to like and subscribe, and see you next time.